One of the most important tasks we have in analysis, and also the most difficult one, is removing any old or even new design characteristics when we produce an analysis specification. That is the emphasis I'll place in this section. In this section we'll cover definition of business process analysis, sample process analysis models, sample analysis data definition, sample analysis process definition, the complete business process analysis specification, and the process analysis methodology. First, let me state my formal definition of business process analysis. Driven by objectives in the project charter, business process analysis is a systematic, top-down technique for studying and decomposing a business area and representing it as a partitioned, detailed specification of business process requirements, a process analysis specification. An analyst is equivalent to an architect. They have the tools to be able to document house requirements, but the customer has to tell them the requirements. I briefly mentioned earlier in the goals section that we should have a mission statement for the organization and objectives for our analysis project, stating what we expect to accomplish by this effort. Those objectives are documented in something called a project charter. It also should contain a list of external customer needs, the events, in an event list that we will use to analyze our organization. The project charter is basically a managerial document from the requesters of the project. However, if it doesn't contain an event list, we need to produce one as the first task in analysis. We use as input to analysis the project charter along with the processing and data in the existing environment. We will also gather any new requirements from business users and staff in the organization. In the rare case where we are doing an analysis for a new business and don't have or don't want to gather the requirements from an existing environment, then we will be getting all our information from somewhere I call a business policy creator, usually the owner or management of the organization. The output or deliverable from business process analysis we call a process analysis specification. This result is used by the system designer, which may be you with a different hat, or the supplier of systems, to create a new system solution. The major components of a process analysis specification are a process analysis model, a dictionary of definitions, and detailed process definitions. We'll cover a high-level view of these on the next slides and then devote a section to each. In the previous slide I mentioned a major component of a process analysis specification is a process analysis model. A process model is used to declare the overall process and data flow through an organization. A data flow diagram is an example of such a process model. On this slide I've shown a sample data flow diagram, also known by its acronym DFD. A data flow diagram is a process model that depicts an organization, or an event reaction, from the point of view of data flowing to and from external interfaces, the context of study, processes, data transformations, and files, data stores. If you haven't seen a detailed data flow diagram before, this is a reasonable example. It's a DFD for an event reaction in my organization. The event is titled Client Wants to Schedule an In-House Seminar. This is an analysis DFD, in other words, one from which all design and implementation characteristics have been removed. People new to this model typically ask, where do we start? Well, we can start with an incoming data flow or control flow from an external interface. In this example, the external interface is a customer requesting a seminar, the event, via a seminar request, which initiates the first process, validate customer, shown on the model. And then we can follow the data flow through its transformations in the processes until it forms a response or responses out to an external interface and or store. In this case, back to the customer as a customer confirmation. However, we can also start by just reading the processes in order. In this example, they are validate customer, check seminar schedule, schedule new seminar, and create customer confirmation. This will give us an understanding of the overall event reaction. The fact that there are no design or implementation details makes this an analysis model. We see the external interface, the customer. We see 4 processes without knowing who or what performs them, human or computer. We see 3 data stores without knowing how they will be implemented, manual file cabinets or computer databases. and we see all the data flowing between those components without knowing their media. I have included one extra symbol, a small slash across any data flow, which indicates the stimulus data flow for a process. I'll talk more about logical conclusions, symbol extensions in a later section. This diagram also shows one complete detailed event reaction, without any department or computer system boundaries. Let me mention here that when we create a data flow diagram, we should at the same time define the data items, such as a seminar request, on that diagram in a data dictionary. So we'll need to back up this DFD with definitions for each data flow and store. We'll also need to document the individual processes in process specifications, such as what is the processing in validate customer, and what's involved in check seminar schedule, etc. In the first slide of this section, I also mentioned a major component of a process analysis specification is a dictionary of definitions. A business dictionary should be part of an organization's overall specification, containing all definitions for data flows, data entities, external interfaces, etc., documented on the analysis models. I prefer to call this set of business definitions a data dictionary, but there are other names you'll find in the technical literatures, such as repository and encyclopedia. When specifying data definitions in analysis, we should exclude any design characteristics, such as media and form, screen, or record layouts. For example, suppose we had a paper shipper receipt in our organization and we wanted to define it in our analysis data dictionary, excluding its design characteristics. We see the physical shipper receipt on the slide here. On the right side of this slide is the analysis definition of the receipt after talking with the business user and finding out the essential business data content and structure. The example shows a business definition using some symbols for the structure of the receipt, such as an equal sign, a plus sign, braces, etc. I'll go over the symbols in detail in a later section. The reason for using the symbols in the definition is to be able to capture an analysis definition that cannot be read ambiguously and removes the old design so as not to restrict any new design. Notice all data items should be defined in our data dictionary, even single elements such as customer name. Another component of a process analysis specification is a set of detailed process definitions. This is where we define the business processing, describing how we turn the input data into output data for each detailed process. The process model is used to declare the overall high-level data flow and processing. However, at the detail level, we specify the business processing with individual process specifications, again without any human or computer design characteristics. The left of this slide shows an example of the human and computer implementation of processing. The human systems will probably have procedure manuals that describe how processing is to be performed based on the physical environment, such as checking the completeness of a document and filing away and retrieving them. The computer system will probably have computer code that describes how processing is to be executed based on such things as computer transaction codes and access and retrieval file structures. Remember, in analysis, we want to capture only the business policy or rules without human or computer design characteristics. On the right side of this slide, I've just shown various means of specifying the analysis essential business policy and rules that should be extracted from human and computer procedures. We can use several forms of representation to document the business processing, such as graphs, charts, decision tables, decision trees, algorithms, if the process is a calculation, just ordinary written text, and if the written text could be read ambiguously, we can use a rigorous form of English called structured English. I've shown some simple examples of these on this slide, and I'll get a little more detailed in a later section. Now, it's worth mentioning that whereas we may easily gather our own organization's human procedures, there may be a lot of business rules hidden in computer programs, such as inside of software packages purchased from our industry's vendors. If we want a complete analysis specification, we should extract any business rules from the computer programs and document that processing also. Let me show an example of a complete business process analysis specification. We can use the complete business process analysis specification as measurable objective criteria to evaluate and accept any new implemented system or systems. The business process analysis specification needs to cover our analysis context of study for the customer events to which the organization responds, model the process and data flow of our reactions to those events through the organization, define all the data items on those models, and specify the detailed processing identified on the process models. So the diagram on the right of this slide shows the components that satisfy this list. The components guided by the event list are a context diagram, a set of process models, a data dictionary, and a set of process specifications. These components are basically the same ones recommended by Tom DeMarco in his original book titled Structured Analysis and System Specification. The next few sections in this tutorial concentrate on each of these components in the process analysis specification. I want to show you a portion of the process analysis methodology I recommend in this tutorial. A methodology can be defined as a guiding set of processes on how to arrive at a finished result. In our case, this is a process analysis specification that can be used to drive a new design for our organization. I've written 2 system development methodologies in my career, and as you already know, I recommend using customer event-driven concepts for creating our process analysis specification. So for each event, we can use incremental intermediate specifications to verify the completeness and accuracy of our final process analysis specification. Now, one of my books was on the subject of re-engineering, and during the era where that term was most popular, many books talked about producing 2 main deliverables. For example, an as-is and to-be view of the organization. Unfortunately, this to me was analogous to going from an old design to a new design without doing a valid analysis in between. A colleague of mine, Tom DeMarco, recommended a better progression of specifications in one of his books. He recommended that we can create 4 specifications through an analysis which he called a current physical, the current design, a current logical, the current analysis, a new logical, the new analysis, and a new physical, the new design. This was better than going from old design to new design, as it acknowledged the analysis deliverables, the current and new logical specifications. However, too many organizations produced all 4 specifications zealously with great expenditure of time and effort. I recommend we evaluate the need for intermediate analysis specifications on an event-by-event basis, and in a large organization, also by a business area basis. The cascading diagram on this slide shows a set of intermediate specifications that we can develop for each event in our analysis effort, the final deliverable from analysis being the new analysis specification. Now, in a worst-case scenario, where we are conducting analysis in a large organization and the old systems and human jobs in place have little or no documentation, and the business users are not familiar with the concepts in this tutorial, then we may want to first make sure we have a good knowledge of how the current environment processes a complete event reaction. We can track the flow of an event stimulus through the existing systems, capturing how it's implemented. In other words, its design characteristics. These may be necessary for business user approval to ensure that nothing is misunderstood or missed from an event reaction. This would produce an existing design specification shown as output in the diagram. As a practical note here, it's probably not necessary to create a formal process model for the existing design. We could just track through our existing systems with a video camera, making sure we capture everything about the current flow of an event reaction through our organization. In a scenario where we are conducting analysis in a small business, or where we have good documentation of the existing systems, we could also immediately develop the existing analysis specification without producing any design documentation. In the best case scenario, where we have good documentation or the business user knows the business policy and has knowledge of the concepts in this tutorial, we could immediately develop the new analysis specification. I tend to jump to this stage when I consult with an organization and I know the reviewer of the analysis model is familiar with my methodology. The new analysis specification is the one that is used to create the new design. Of course, these models can be at different stages for different events, especially if there are many analysts on a team working on different event reactions. We want to be careful not to do too much study of the current design for something that is not going to be used in the future system. Let me use my banking example again to make my point. If we are chartered with studying a bank's operations, and we spend weeks studying the manual teller payroll processing, in other words, studying an aspect of the current human design, and end up implementing online or mobile banking in the new design, then we just wasted weeks of analysis, as we won't have manual tellers to pay, and so the models of the teller payroll system will be of no use. However, if we studied the manual teller processing for deposits, withdrawals, transfer and inquiries of funds, we have not wasted any analysis effort, as those events are aspects of business and will be necessary regardless of any old or new design. I should also add here that it's quite typical to find no new requirements once we've discovered the essential business from the existing design. In other words, the existing analysis specification is the new analysis specification, and the analysis effort is used to enable a better new design. If it's of help, I've put a little table in the top right of this slide, using the generic words of what, depicting analysis, and how, depicting design. It shows the progression of the specifications. The existing design identifies how the business is currently done, and the existing analysis identifies what is currently done. The new analysis identifies what will be done, and the new design identifies how it will be done. That's the end of this section.